Okay, hello everyone here at Lakebed 2030 and out there in the go-to webinar world. My name is John Bright and I work at the Thunder Bay National Marine Sanctuary. My background, education background, is in marine archaeology and biology. And over the course of about a 12-year career working with the National Park Service, working with NOAA, and working with the private industry, I've actually spent quite a bit of time engaged in scientific field operations that involve some type of seafloor mapping. I think a lot of the methods that are germane to informing archaeological research questions are also the types of methods that are more broadly applicable to other fields of study that can also use that bottom mapping data. So there's I think a neat synergy that's driving the advancement of a lot of these archaeological or cultural resource type studies in the Great Lakes and providing data sets that archaeologists can use, but that are much more broadly utilized by other groups to do other types of analysis and advance other fields of study. Anyhow, if we could go ahead to the next slide and then the one after that. There we go. Okay. So the Thunder Bay National Marine Sanctuary is one of the many marine protected areas that are administered by NOAA's Office of National Marine Sanctuaries. And we've heard from Russ Green and Madeline Roth talking about work being done at sites within the Great Lakes, but we just want to kind of reiterate our position as a site within that MPA program. And I've actually got a slide here that's a little bit out of date. So when this slide was made, or since the slide's been made, both the Wisconsin and Mallows Bay sites have been designated as national marine sanctuaries. As Russ mentioned, that occurred in Lake Michigan in August, and there's an accepted nomination for the Lake Ontario site as well. My background, I started at Thunder Bay National Marine Sanctuary in 2015. However, the site was designated in the year 2000, and it was expanded almost tenfold in 2014. So a lot of the prior survey work and mapping that took place here was done by other sanctuary personnel, was done by other research groups. However, that iterative nature of those projects and the expertise and experience that it brought to the sanctuary propelled us to where we are today and our current capabilities and the status of all of the mapping work that has taken place within the Thunder Bay sanctuary boundary. Next slide, please. So as it sits at present, following that 2014 expansion, Thunder Bay National Marine Sanctuary encompasses 4,300 square miles of Lake Huron. That's 11,136 square kilometers. It is designated primarily focusing on cultural resources, those most conspicuous ones being the historic shipwrecks that are out there in the lake. However, the sanctuary also encompasses areas of really interesting geology. It includes the Alpena Amberley Ridge that runs through the central part of the sanctuary. It includes several documented submerged sinkholes and a myriad of other natural resources as well. So this boundary represents a lot of challenges in terms of a locale for conducting bottom mapping. We have some of the deepest parts of the lake, as well as this extensive network of shallow coastlines. There's embayments. There's parts that are close to marinas and harbors. There's parts that are far away that are more remote. And so there's a kind of unique challenge that's been encountered by the sanctuary personnel and our research partners that have been working here in how to effectively deploy bottom mapping equipment through this array of different environments. Next slide, please. But when you come to our headquarters in Alpena, Michigan, we see the sanctuary as it is now, 20 years after designation, which includes our large Great Lakes Maritime Heritage Facility. That's the museum, office, and operational space in downtown Alpena, including our large marine test tank, our dive locker, a makerspace, kind of multi-purpose education outreach and testing facility. You also see the network of shipwreck mooring buoys that are out in the lake. So this joint activity between NOAA and the state of Michigan manifest in all of this infrastructure and resources that have been accumulated over 20 years. Next slide, please. And it would be kind of impossible to discuss the state of mapping and field operations in Thunder Bay without mentioning the Great Lakes Environmental Research Laboratory, which is an entity in a separate NOAA line office, but there's been a very in-depth interagency collaboration between the Office of National Marine Sanctuaries and the Great Lakes Environmental Research Laboratory to share scientific expertise, to share assets, namely vessels, as well as survey equipment, and supporting each other's missions here. So it's, I think, from kind of this point on in the talk, mentioning our work being NOAA Thunder Bay National Marine Sanctuary is sort of synonymous with the contribution that the Great Lakes Environmental Research Laboratory has made with their vessels, with their equipment, with their scientific expertise, because in pretty much all of the work that we do out on the lake, we work in tandem with GLERL. Next slide, please. So to talk about the current state of our assets, we just want to give a rundown for everyone that's participating to know what type of equipment, what type of software, and what types of capabilities that we have. And we'll discuss some prior projects, how these have been deployed within the boundary of the Thunder Bay National Marine Sanctuary. But really, these resources are mobile, and we are able to conduct the types of work that we are using as examples here throughout the Great Lakes. And even though sort of beyond the scope of this, there's been projects in the last few years where we have worked outside of the sanctuary's boundary to support these collaborative efforts between NOAA and other federal academic partners, other states as well. So the kind of primary capability, what gets all this gear out onto the water and working, are vessels. These are all GLERL vessels. So the largest GLERL vessel being the one in the top, the Laurentian. It's an 80-foot platform that was configured for multiple scientific operating work scopes, but to support geophysical survey. It has a transducer well that we can deploy a multibeam sonar through. We have a over-the-side pole that we can also configure to deploy sonar. It has a mounting up above the wheelhouse for putting GNSS antennas, and then a lot of options for integrating other navigation equipment on board, as well as running cables to connect workstations and get a survey suite ready to deploy. We've used it most recently to do multi-beam surveys, but it's been used in the past for side-scan surveys as well. It's got accommodations for up to 14 people on board, so you can field a pretty extensive party for online activities, even doing some offline data processing, and it can maintain a 24-hour continuous operating mode. The two vessels on the bottom are larger day operations platforms. RV Storm is bottom left. That also has a transducer well where a multi-beam sonar can be mounted. It's had actually several models of multi-beam sonar integrated on board. It's got a hydrographic survey winch with an armored coax cable that you can deploy side-scan sonars, magnetometers from the back of the vessel. So you could do multi-instrument deployments with that. Dedicated science lab as well. So able to operate in kind of a extended day operations mode. And then the final vessel on this slide is a newer vessel that's being brought into the GLERL fleet, which is a swath boat. It's a catamaran hull vessel that will be able to conduct operations in more elevated sea state conditions while maintaining vessel stability, and will be configured for, again, deploying those types of hydrographic or geophysical survey equipment. Next slide, please. GLERL and Thunder Bay also deploy several small boat capabilities. So these are things that are trailerable. I'm taking a little pause here. I haven't seen the slide click over yet. There they are. So these are trailerable assets that we can move by road to a project area, deploy. The vessel on the top is actually owned by the National Park Service. It's the RV Echo. I believe it was used quite extensively up here in the Great Lakes and has been, for the last 2 years, operated under a joint sort of management plan with NOAA and the National Park Service. It's equipped with multibeam sonar and navigation equipment. And then the bottom vessel is the R3011. A small boat that was supporting some of the OET mapping that was presented in the keynote presentation a little earlier, and again can be configured for supporting larger vessel operations like collecting sound velocity casts, supporting autonomous vehicle deployments, or could be configured for side-scan sonar, magnetometer, towed equipment, sort of hand deployed in a lighter, near coastal operating mode. So this array of vessels can support numerous sensors, numerous operating modes, 24-hour continuous down to day operations, things that are trailerable versus things that would need to be transited to a project area. Next slide, please. As far as instrumentation, Thunder Bay and Glural each own inertial navigation systems. These are PAWS MV systems. The one owned by Thunder Bay is an older V4 system. The one in use with Glural is a newer V5 system. These both have components that are sort of hard mounted into both the RV Storm and the RV Echo, although they could be removed and integrated onto the other vessels. So these systems provide the precise navigation that we need to do the types of high resolution mapping that we're capable of currently and that other groups and other science teams are using, as well as provide the kind of general navigation we would need for a side scan or magnetometer survey used more specifically for cultural resources. Next slide, please. The way these systems are currently configured on board, we're not using any like real-time kinematic corrections. We're basically just running them in either a CA mode, or if we're able to stream in a WAS corrected source, then we can do a slight improvement on the real-time data acquisition. But our site has a software license for the Applanix mobile mapping suite, so we can generate post-processed navigation files. We have actually a smart-based license, so we can get pretty detailed correction data, or pretty detailed network of correction data, apply that to our recorded navigation files, and then inject that into our sonar mapping project to substantially improve the quality of the data that we collect. Next slide, please. Of course, we have Sidescan Sonar. There's a Klein 3000 system here at Thunder Bay, and we have a fairly large cache of parts as well to be able to service that unit and keep it in operation. That's a 100, 500 kilohertz Sidescan Sonar system that's good for doing hazard surveys, good for doing cultural resource surveys, looking for large shipwrecks, et cetera, things that have a great degree of relief off the bottom. It can be a really good adjunct to a multi-beam survey where we're interested in bottom mapping as well. So we can collect the Sidescan Sonar survey and then reference it to features in multi-beam and improve the side scan positioning. And our program has access to SonarWiz licenses to do post-processing on the Sidescan Sonar data. Next slide, please. We also have a Geometrics G882 marine magnetometer unit. This is something that can be deployed in tandem with a Sidescan Sonar unit. So off our boats like the RV Storm, we can have a single vessel platform where there's a multi-beam navigation system, and then deployed through a towed configuration, a Sidescan Sonar, and a magnetometer. So we could put a 3-instrument suite out off of a single platform and collect several different data types simultaneously. An interesting thing about the Geometrics units is that they can be kind of coupled together. So 2 magnetometers can be fixed in a rigid frame, and we can actually deploy that as a transverse gradiometer, which is really great for UXO surveys, as well as trying to detect cultural objects, cultural materials, very similar to the mode that was used and described by Madeline and Russ in Wisconsin for working in those sandy areas where there's potential for objects to be buried. So in addition to the magnetometer unit, we have access to a suite of software programs. We can process and visualize that magnetometer data in ArcGIS, and then through industry partnerships that were also characterized in that earlier talk with marine magnetics and other industry partners, we can access some higher order processing and visualization softwares that would better allow us to integrate the results of a magnetic survey into products like bathymetry or Sidescan Sonar data. Next slide, please. Of course, multibeam sonar, we have between Thunder Bay and Glurl, 2 Kongsberg EM 2040 multibeam units. Those are set up on some kind of customized mounting options. We're able to deploy it off Laurentian, able to deploy it through the Echo, able to deploy it in RV Storm. So we've got a pretty good track record of setting up those mounts and getting that sonar unit integrated on board a boat and interconnected with the navigation system, and then doing the types of survey control, mobilization, testing, and verification to get all that dialed in and producing the kind of data quality that we want for charting and for benthic mapping. And we're doing all that processing of multibeam data, backscatter data in Keras. Next slide, please. So those are our current assets, and these are things that are, some of these equipment items are fairly new. Some of these vessel platforms, we're still, like we said, just this year doing multi-beam work off of the RV Laurentian and kind of refining some of those deployments. But if we were to take a snapshot of the current spatial coverage of different data types in the sanctuary, we have this shapefile that was produced by NCOS looking at all the different data types of surveys conducted in Thunder Bay National Marine Sanctuary, most of these being conducted following our establishment and then the expansion of the sanctuary. And it's an amalgam of topo-bathy LiDAR, it's an amalgam of Sidescan Sonar only, a mixture of Sidescan Sonar and bathymetry data, some bathymetry only, stuff that's been collected by AUVs, stuff that's been collected by surface vehicles. So I just want to go through a couple of these as case studies, leaving room for many of our other partners who are going to be presenting to discuss specific results from surveys that are being done. The big take home from this being that there's a lot of area inside that boundary that is still yet to be mapped. The next slide, please. But what we want to highlight is that the sanctuary wasn't built overnight. So here we see on top the Great Lakes Maritime Heritage Center as it is today, and then as it was many, many years ago. So the designation of the sanctuary in the year 2000 didn't bring with it this cascade of vessels, remote sensing survey equipment, software expertise. Rather, that stuff was gained through initially working through these really large and elaborate partnerships that brought the expertise here, that demonstrated the value of these surveys, that showed the ability to generate meaningful results and sustain these continued partnerships. And so the trajectory of 20 years in Thunder Bay and collecting all these data types, doing all the survey and producing these results is something that is probably a blueprint for the similar trajectory for new National Marine Sanctuary sites coming online within the Great Lakes. I'm sure much to Russ's chagrin, there's not a cascade of vessels and remote sensing equipment and everything that are going to show up in Wisconsin. It's going to be a similar process of working with these partnerships, bringing resources together, testing new methodologies and deployments, and building capacity along the way. So the Thunder Bay story is a kind of a roadmap for how this will preview the development of capacity throughout a Great Lakes system of national marine sanctuaries. Next slide, please. So one of the first big projects that happened shortly after the designation of the Thunder Bay site was a large Sidescan Sonar effort that took place between 2000 and 2001, and here we can see the sort of footprint of that coverage. This was confined to the original Thunder Bay National Marine Sanctuary, and many of the groups that are and people and researchers that are now part of the the Ocean Exploration Trust were part of this effort when that organization was previously the Institute for Exploration. So it was kind of one of the flagship survey projects that kicked off with the establishment of the sanctuary. And in fact, we can see photo documentation of Dwight Coleman participating in those operations, and then being mentioned, of course, leading the mapping exercises that were ongoing this field season as well. So next slide, please. In addition to that large sort of flagship project, there were multi-year collaborations that were set up, and here's some an example of that being the Sidescan data that was collected by the University of Rhode Island, and several field efforts taking place between 2002 and 2008, combining that with field schools for training students as well. So the sanctuary being a destination for that type of research, and in a place where there was at the time a clearly demonstrable need to start to fill in some data gaps, better refine our positioning of cultural resource sites, and map areas in and around the sanctuary boundary. Next slide, please. So fast forwarding then to 2011, a lot of the work we've done up to this point had been side-scan surveys. By this time, we started working with multi-beam sonars in addition to side-scan, and using that as a methodology to help us both identify cultural resource sites, but also develop bathymetry, backscatter, and more broadly applicable scientific mapping products. So 2011, Sony and Intel sponsored a multi-beam mapping exercise. This was a multi-scalar project in the sense that it went from mapping to ground truthing with ROV and divers in the course of a single field campaign. Next slide, please. And this was sort of in between a more prolific introduction of multi-beam sonar mapping within the Thunder Bay and Global team. It's between 2010 and 2014, the RV Storm was configured to operate with both Kongsberg and Reson multi-beam units. The kind of installation was set up, the sensor offsets and sensor mounts were all set up at this time, and it proved the RV Storm a capable mapping platform that conducted a lot of work in the sanctuary. Next slide, please. 2007, we brought the RV Laurentian into the fold as a 24-hour mapping platform. Here we see the pole mount that was used to deploy an EdgeTech 6205 sonar, and yet another familiar face from today's Lakebed presenters, Dr. Art Trimbanis and a group from the University of Delaware leading mapping effort there, working in the expanded area of the sanctuary and conducting quite a few good days of bottom mapping. Next slide, please. And so that kind of those couple sort of case studies there showing that the sanctuary can do really meaningful work with partnerships, and how much we depended on those partnerships, and how much the experience gained from doing that work helped inform how we can better equip our vessels, train our personnel, and implement the mapping methods that were used during those projects to bring more of that capacity in-house, so that we can start to provide mapping services for ourselves in these areas of the sanctuary where work needs to be done, as well as to other MPAs in the Great Lakes region, as well as to other partnerships, other federal, state, academic entities that may want to utilize or collect and have this kind of data. We're capable of acquiring, processing, and delivering all that stuff, and hoping to continue to build that capacity at Thunder Bay and then at the other ONMS sites coming online in the Great Lakes. Next slide, please. And so as much as possible, we are trying to move this data, the legacy data that we have from the past 20 years, into portals where it can be accessed by other groups. So moving stuff to the moving data to the NCEI portal, which we can see here, just sort of zoomed in some of those footprints of surveys that were shown in the spatial assessment, being data products that are available, and a few others that'll be in the queue there at NCEI. Next slide, please. And Thunder Bay also has a digital atlas where some of these footprints are shown as well. And so we want to be able to host the data that we collect online so that it's accessible to users who are interested in viewing or conducting any kind of additional analysis and interpretation with those data sets, getting it out to this network of partners so that we can truly realize the map once and use many philosophy that is really prolific right now. So we're trying to put as much of this up onto the web as we can, and if there's data sets that folks are interested in, then reach out to us and we can try to direct the best place to find those things. So I think the next slide should be the closing slide. That's right. So one more down is my contact information. One more slide down is my contact information, so you can reach out to myself or any of the other NOAA presenters that you have been able to see here. Tomorrow, Stephanie Gondula from Thunder Bay will be presenting, as well as Phil Hartmeyer will be presenting as well. So you'll be able to catch a couple more of the Thunder Bay staff and different sort of presentations related to this work that's been happening if you stay tuned for that as well. So thank you, and if you have any questions, hopefully I can get you a good answer.
We do have one question here for you, John. If you can please comment on any work that has happened on the Amberley Ridge and what the purposes of those mapping efforts were.
So there's been work with the U.S. Fish and Wildlife as well as the University of Michigan to do benthic mapping on the Alpena Amberley Ridge. We've collected those data because we wanted to map the geological formations for the sake of having that data at the sanctuary, but provided it to managers at Fish and Wildlife for assessing biological habitat, and provided it to the University of Michigan for archaeological studies.